AI broke the internet again, and this week has been absolutely insane. Genesis AI reveals their first general-purpose robot built around human-level dexterity instead of trying to look human. Unitree drops a new humanoid platform with a Blackwell GPU on board, delivering over 2,000 teraflops of compute. Xpeng's CEO takes personal control of the company's robotics division as mass production becomes imminent. Figure reveals they've scaled their factory from building one robot a day to one robot an hour. Boston Dynamics Atlas finally leaves the lab and starts working inside a real Hyundai factory. We have a new open source motion tracking model that can learn from 2 billion frames of data and pull off a 360-degree spinning kick. Deep Robotics shows off their all-weather humanoid, sprinting and jumping with a fire extinguisher in hand, and a lot more. So let's jump right in. First up, this is a pretty exciting reveal. It's called Eno, and this is Genesis AI's first general-purpose robot. Now, what's interesting about Eno is the design philosophy. Instead of trying to make a robot that looks fully human, like a lot of companies are doing right now, Genesis designed Eno around human capability instead. In other words, they prioritized mobility, dexterity, and real-world functionality over just looking like a person. So how this works is Eno has a wheeled base with a tower of articulated panels rising from it that can adjust height and reach in real time and fold down for compact storage when it's not in use. At the center of the system are arms fitted with proprietary dexterous hands that actually match the form and function of human hands. So the robot can use the same tools and interact with the same environments that were already built for people. Now, the awesome thing about this is the brain behind it. Eno was developed alongside Genesis's own AI model called Gene. So the body and the brain were built together as one integrated system from day one. Gene gives Eno human-level dexterous manipulation with millimeter precision. And unlike a lot of robots that just execute one command at a time, Eno can actually manage an entire objective from start to finish. Given a high-level goal, it understands context, retains memory, and dynamically plans multi-step tasks over extended periods of time. They're also building in something they call a cognitive interface, which is basically a screen on the robot itself that shows its intent, reasoning, and what it's currently doing. So people working around it can actually understand what it's about to do next. Now, Eno isn't available to buy just yet. Genesis plans to begin production and targeted customer deployments by the end of 2026, starting with manufacturing, logistics, and laboratory customers, followed by hospitals and hotels, with home and outdoor use coming after that. If you're interested in reading further, I'll link to this page in the description below. Also this week, Unitree releases a pretty powerful new humanoid platform. It's called the H2 Plus, and this is a reference platform built for full-stack robotics development, meaning Unitree is essentially handing developers a ready-made foundation to build on, rather than just selling a finished consumer product. Now here are the actual specs for your reference. It's powered by an NVIDIA Jetson Thor with a Blackwell GPU on board, delivering 2070 T-flops of compute at FP4, a 14-core ARM CPU, and 128 gigabytes of unified memory. That's a genuinely massive amount of onboard compute for a humanoid robot to be carrying around. It stands about 1.82 meters tall, weighs around 70 kilograms, and has 31 degrees of freedom across the whole body, including 7 per arm and 6 per leg. Maximum arm torque is 120 newton meters, and maximum leg torque is 360 newton meters. It also has a rated arm payload of 7 kilograms and a peak payload of 15 kilograms. And the hands are actually really impressive on this one. It comes with dual Sharpa-Wave tactile 5-finger dexterous hands, giving it 22 active degrees of freedom in the hands alone, and 75 total degrees of freedom across the entire entire body and hands combined. The awesome thing is this whole platform is built to run on NVIDIA's Isaac GR00T open foundation models, Isaac Sim, and Isaac Lab for training and testing policies before real-world deployment, and Isaac ROS middleware to actually move those trained policies onto the robot. If you're interested in reading further, I'll link to this page in the description below. Next up, we have some pretty big robotics news out of China. XPeng's CEO, He Xiaopeng, announced he's personally taking over as head of the company's robotics division, effective immediately. Now you see, this isn't just a leadership reshuffle. He says this move comes, in his words, on the eve of mass production and commercialization of XPeng's human-like iron robots, which first debuted last year. XPeng has set a goal of starting mass production of iron robots by the end of 2026, with the humanoids expected to see trial use inside XPeng's own retail stores before being delivered to commercial customers in China and overseas starting in 2027. Now, for context, robotics hardware and related AI models are expected to become one of XPeng's main drivers of revenue and gross margin going forward, according to comments the CEO made on an earnings call back in May. So this isn't a side project for them anymore. It's becoming core to the business. This also follows news that a core executive on the Iron project had recently left the company, so taking direct control himself is also a pretty clear signal of how seriously XPeng is treating this transition into what they're calling physical AI. If you're interested in reading further, I'll link to this page in the description below. Also this week, Figure AI shares a pretty massive manufacturing update. It's called BotQ, and this is Figure's high-volume manufacturing facility for their Figure 03 humanoid robots. Now here are the actual numbers for your reference. Figure has delivered over 350 of their third-generation humanoid robots so far, and they've increased their production rate from 1 robot per day to 1 robot per hour. That's a 24 times throughput improvement in under 120 days. That's actually an insane scaling rate for physical hardware manufacturing. Getting there wasn't just about speed. Their end-of-line first-pass yield is now over 80% and improving weekly. Their battery line has hit a 99.3% first-pass yield and has shipped over 500 battery packs. And they've produced over 9,000 actuators across more than 10 different SKUs. Each robot also goes through more than 80 functional verification tests before it's signed off, including multi-limb stress testing and burn-in sessions where the robots perform full-body exercises like squatting and shoulder presses thousands of times to catch early failures before deployment. Now, the awesome thing is all of this scale is directly feeding their AI development. The larger their fleet gets, the more real-world data they generate for Helix, their humanoid AI model. And this actually already unlocked a new capability they're calling perception-conditioned whole-body control, which lets the robot see and anticipate stairs, ramps, and uneven terrain, instead of just walking blind across flat ground. If you're interested in reading further, I'll link to this page in the description below. Next up, Boston Dynamics Atlas robot finally leaves the lab. This is actually a pretty significant milestone. Atlas was deployed for field testing at Hyundai's new manufacturing facility near Savannah, Georgia, marking the first time Atlas has worked outside a lab on actual production tasks. Here's an example. CBS's 60 Minutes actually got access to film this, and you can see Atlas autonomously sorting roof racks for the assembly line. No human assistance needed. As you can see in the footage, this is genuinely Atlas operating completely on its own, which is a pretty big deal since this is its first time doing real work outside controlled lab conditions. Now, for your reference, Boston Dynamics says Atlas learns mostly through teleoperated demonstration rather than manual programming. A human operator wears a VR headset and guides the robot's arms, move by move, through a task multiple times, and that data is used to train the robot's AI models so it can eventually perform the task autonomously. And the brains behind this are actually powered by NVIDIA chips, the same kind of hardware that helped launch the broader AI boom, processing all that collected data to move Atlas closer to something resembling common sense. Now, I'll be honest, Atlas still can't do a lot of basic things a person can, like putting on clothes or pouring a cup of coffee while walking around. But Boston Dynamics says they finally see a real pathway to get there, thanks to this shift toward AI-driven learning instead of hand-coded movements. All of Atlas's 2026 production is already fully committed to Hyundai and Google DeepMind, with Hyundai planning to build a dedicated factory capable of producing 30,000 robots a year. If you're interested in reading further, I'll link to this page in the description below. Also this week, we have a really impressive new open-source motion tracking model. It's called Humanoid-GPT. And this can track extremely agile, complex human motions on a real humanoid robot in a zero-shot way, meaning it doesn't need to be specifically trained on the motion beforehand. Now, you see,
Also,
the problem
this week,
with
we have
most
a really
humanoid motion
impressive
trackers
new
right
open
now
source
is what the
motion tracking
researchers
model.
call an
It's called
agility
Humanoid-GPT,
generalization trade-off.
and this can track
the tracker
extremely
can either
agile,
handle
complex
high
human
dynamic
motions
on a
well,
real
or
humanoid
it can
robot
generalize
in
to
a zero-shot
motions
way,
it's never seen
meaning
before.
it doesn't
But
need to be
historically,
specifically
not
trained
both
on the
at the
motion
same time.
beforehand. So how this works is the team assembled a massive 2 billion frame motion corpus by combining every major motion capture dataset out there, plus a ton of their own in-house recordings. They then trained specialized motion experts using reinforcement learning and distilled all of that expert knowledge into a single, transformer-based generalist tracker. Now, for your reference, here's how it compares to Sonic, which was previously the strongest generalist tracker out there. Sonic was trained on around 100 million frames. Humanoid-GPT was trained on 2 billion, roughly 20 times more data. And in their side-by-side comparisons across daily motions, dance motions, high dynamic motions, and balance motions, Humanoid-GPT consistently shows smoother behavior, more expressive movement, and steadier balance than Sonic. Here are some examples. You can see it running on a real Unitree G1 in everyday home scenarios. And in their extreme motion tests, with just a few steps of lightweight fine-tuning, it can pull off a full 360-degree spinning kick and a Webster flip, both of which are motions far outside anything in its original training data. The awesome thing is, they've released this already. The code is on GitHub, and the paper is on Archive. This was accepted at CVPR 2026 from researchers at Tsinghua University, Galbot, Peking University, and several other institutions. If you're interested in reading further, I'll link to this page in the description below.
Also, this week, we have a pretty cool demo from Deep Robotics. It's called the DRO2, and this is their all-weather industrial humanoid. And they just released new footage showing it sprinting across uneven terrain, jumping over obstacles, and carrying a fire extinguisher. Now, for your reference, the DR02 stands 175 centimeters tall, weighs about 65 kilograms, and has an IP66 rating, meaning it's fully sealed against dust and water. It can operate in temperatures from -20 to +55 degrees Celsius, which is actually a huge deal for a robot meant to work outdoors year-round. At its original launch, it was rated for a 20-kilogram total payload, 10 kilograms per arm, and a walking speed of 1.5 meters per second, with a 4 meter per second sprint speed for emergency situations. It runs on an NVIDIA Jetson AGX Orin platform, delivering 275 TOPS of compute, and has 31 degrees of freedom for full body manipulation and locomotion. Now, Deep Robotics says this new demo shows enhanced payload capacity and obstacle crossing capabilities, geared toward real-world industrial applications like firefighting. Now, I'll note this comes right as Deep Robotics is pursuing a $367 million IPO on China's star market, just days after rival Unitree secured fast-track approval for its own IPO, seeking around $620 million. So part of this demo is also clearly aimed at investors, showing off the hardware side of things, while the real test going forward will be how autonomous these capabilities actually are outside of a scripted demo. If you're interested in reading further, I'll link to this page in the description below. And that sums up all the highlights in robotics this week. Let me know in the comments what you think of all of this. Which piece of news was your favorite? And which tool are you most looking forward to trying out? As always, I will be on the lookout for the top AI news and tools to share with you. So if you enjoyed this video, remember to like, share, subscribe, and stay tuned for more content. Also, there's just so much happening in the world of AI every week. I can't possibly cover everything on my YouTube channel. So to really stay up to date with all that's going on in AI, be sure to subscribe to my free weekly newsletter. The link to that will be in the description below. Thanks for watching, and I'll see you in the next one.